Hi, today I'll be going over 2010 AMC 8 problems 21 through 25, starting off with problem 21. Huey is an avid reader. She bought a copy of the bestseller Math is Beautiful. On the first day, Huey read 1/5 of the pages plus 12 more, and on the second day, she read 1/4 of the remaining pages plus 15 pages. On the third day, she read 1/3 of the remaining pages plus 18 pages. She then realized that there were only 62 pages left to read, which she read the next day. How many pages are in this book? Okay, so an easy approach to this problem is working backwards. So she had 62 pages left at the end of the third day after she read that many pages. And then working backwards, she read 1/3 of the previous day's pages plus 18. So since she took off the extra 18 pages, we're going to add back the 18 pages to get that it was 80 pages. And then we have that 80 pages is equal to 2/3 of the previous day's total because she read 1/3 and then had 80 pages. So we can multiply by the reciprocal. 80 times 3/2 to get day 2's total. Reducing, we have that 120 is equal to the previous day's total. Doing the same process, we add back the 15 pages to get that day 2 had 135 pages. And then 135 is equal to 3/4 x. And then again, multiplying by the reciprocal, 135 times 4/3 is equal to x. And then reducing, that's 45, yes. And then multiplying, we have that was 180 pages. And then doing this one last time, adding back the 12 pages, that's 192 pages. And then that is equal to 4/5 of the total number of pages. So we can multiply by the reciprocal one last time. Times 5/4 is equal to x. Reducing, that's 48. And then 48 times 5, which is equal to 240. So our answer is C. Okay, problem 22. The hundredths digit of a 3-digit number is 2 more than the units digit. The digits of the 3-digit number are reversed, and the result is subtracted from the original 3-digit number. What is the units digit of the result? Okay, so these problems are quite easy because all you have to do is set up an example and you'll have your answer. So let's say I have the number 482. This satisfies the first restraint because, the only restraint, because the hundredths digit, which is 4, is 2 more than the units digit, 2. So now the digits are reversed, 284, and they are subtracted. So we'll do some quick subtracting. We get that our units digit is 8. So what we can do is do another example. This time I'll do 725. The reciprocal is that the reciprocal of that is 527. Doing some more subtraction. We also get that the units digit is 8. So what we can do is try this another time just to confirm it. I'll have 634 and 436. Subtracting 8, 1, which also results in a units digit of 8. So we have already confirmed that our answer is 8. But let's think about this. If you have the number 15, the units digit is 5, and let's take 7 since it is 2 more. So 15 minus 7 is 8. And then let's take 12 minus 4. 4 is 2 greater than 2, which is also 8. And then in our last example, we used 14. 14 minus 6, because 6 is 2 greater than 4, which also results in 8. So technically, you didn't have to do all the work up here. But, just to confirm it, you can always do that to solve your problems. Okay, problem 23. Semicircles P, O, Q, and R, O, S pass through the center of circle O. What is the ratio of combined areas of the two semicircles to the area of circle O? Okay, so first of all, what we can do is determine the radius of O, which is just this. So that would be, since we know the height right here is 1 and this length right here is also 1, we can use the Pythagorean theorem. 1 plus 1 equals c squared, so c is equal to the square root of 2. So the radius of the larger square is the square root of 2. So calculating the area, which is pi r squared, which is the square root of 2 squared times pi, which equals to 2 pi. And then we have that the radius of the smaller circle is just 1. So that means the area of the circle is just 1 squared pi, which equals just pi. So the ratio of the combined areas of the two semicircles, which is just a regular circle with radius 1, to the area of circle O, well, then that would be just pi over 2 pi. And reducing pi, we have that the answer is 1/2. So our answer is B. Okay, problem 24. What is the correct ordering of the three numbers 10 to the 8th power, 5 to the 12th power, and 2 to the 24th power? So, one thing that you've probably noticed about big numbers in math competitions like the AMC is that no one's expecting you to solve out all of these big powers. So that means there must be some trick, and there is. So if you look closely at all of the exponents, 8, 12, and 24, you notice are all multiples of 4. So what you can do is take the fourth root of all the numbers, my square roots look horrible, 2 to the 24. Okay, so if you know your exponent rules, then if you have power to a power or power to a root, then you just divide. So 10 to the 8th to the 4th root is just 10 to the 2nd power, because 8 divided by 4 is 2. And then that this right here is equal to 5 to the 3rd power. And then this right here is 2 to the 6th. Now, all of these right here are relatively simple powers that we've probably all learned before. 10 squared is just 100. 5 to the 3rd is 125. And then 2 to the 6th is 64. So now we can rank the numbers. This is from least to greatest. So least to greatest would be 64, 100, and 125. So that would be 2 to the 24, 10 to the 8, and 5 to the 12. So finding one that matches, our answer is A. Okay, problem 25. Every day at school, Joe climbs a flight of 6 stairs. Joe can take the stairs 1, 2, or 3 at a time. For example, Joe could climb 3, then 1, then 2. In how many ways can Joe climb the stairs? Okay, so we're going to start from step 1, which is ground floor. And then there's only one way to do this, from 0 to 1. So I'll say that is one way. And then from 1, so that's 0 to 1. And then from 0 to step 2, then we can either take 2 small jumps or take a 2-step leap from step 1. That's 1 way plus 1 way, which equals 2 ways. This is from step 1 to step 2. And then now for step 2 to step 3, we can either take 3 small jumps, a big 2-leap jump, and take 1 small jump, or take a 3-leap jump and take 1 small jump. Or we could take the 1 small jump right here and take a 2-leap jump right here. I know it looks confusing, but once I show you the trick, it'll be much easier. So that was 2 plus 1 plus 1, which equals to 4. The pattern is already starting to emerge, but once we do the next step, it will be much more apparent. So, again, we can either take the 4 small jumps, one way, take a 2-step and then 2-step, another way, or we could take a 3-step and take another step, or we could take a small step and then take a 3-step. Okay, and then, let's see, or we could take a small jump, take a 2-leap jump, or take a 2-leap jump and then small jump. And then our last way is, let's see, a 1. So we could take a 1 jump, a 2 jump, and then a 1 jump. So 1, 2, 1, which is our last way. So all that added up together is 7. And then simplifying all this junk up here, it is just simply 4 ways plus 2 ways plus 1 way, which equals 7 ways. So now you can kind of see the pattern here. You take the previous number, plug it in at the front, and then take the 2 numbers before it and add it together. 4, and then take 2 from before, and then take the 1 from before, so add all together, it equals 7. So now, not having to do all this big junk over here, we can just use our small trick. 7 plus 4 plus 2 is equal to 13. So now, all we have to do is do one more to go from step 5 to step 6. 13 plus 7 plus 4, which is equal to 24. So our answer is E.